In this example, we're going to be reviewing some of your factoring methods. Now let's just start by recalling that factoring is the opposite of expanding. So if I start with two binomials and I multiply them together, that is called expanding. Factoring is the opposite. So I would start with something in expanded form and I would be trying to break it down into its factors. Say we want to find the x-intercepts of a function. Okay, so then we would need to be able to factor as a first step. So we're going to review 4 of your methods today. The first one being common factoring. Common factoring is where we look at all of the terms in the polynomial and look for what factor or factors they have in common. So here in the first example, I would look at the 4 and the 6, and I would say the greatest common numerical factor between those two terms is 2, and between the x squared and the x, the common factor is x. So my common factor is 2x, and if I divide both terms by 2x, I would be left with 2x minus 3. Always remember you can check your factoring by expanding. So if we expanded this back out, it would be 2x times 2x, which is 4x squared, and 2x minus, multiplied by negative 3, which is minus 6x. In your next example, the common factor between your numbers is 2, and for your variable parts of the terms, you always choose the smallest exponent. So the exponents on m here are 3, 2, and 1, so your common factor will be m. So common factor is 2m. When we divide each of these terms by 2m, we're left with, not 2. Let me fix that. Just m squared on the first one. So m squared minus 2m minus 8. And again, you could check that one by expanding. In the last one, there's no common factor between 4, 4, and 5. So I go to the variable parts of the terms now. They all have an a, at least one, and they all have a b. So my common factor is a, b. Again, choose the letters with the lowest exponent. Dividing all terms by a, b, I'm left with 4b plus 4a minus 5. So that's common factoring. You should always check for a common factor first, because even questions that require one of the other methods can often be simplified by common factoring first. The next type we'll review is simple trinomials. Simple trinomials are trinomials that have a coefficient of 1 on the squared term. So notice all of these questions have that. We don't write the 1, okay, but the fact that there's no number there insinuates that it is a 1. This is the method where we often use SPN, sum product numbers. So in this first one, I know the two numbers I'm looking for have a sum of 5 and a product of negative 6. So two numbers that add to 5 and multiply to negative 6. Those numbers would be 6 and negative 1. So in my two brackets, in factored form, I know it will be x plus 6 and x minus 1. Next one, my sum is negative 3, my product is negative 28. Two numbers that have a sum of negative 3 and a product of negative 28 are negative 7 and positive 4. So my factors are m minus 7 and m plus 4. And in the last one, we need two numbers with a sum of negative 5 and a product of 6. Those numbers are negative 2 and negative 3. Okay, that is factoring a simple trinomial. When you have 4 terms, typically your only option is to factor by grouping. And what that means is pair up your terms. So I'm going to look at this pair and this pair. And common factor each pair, first of all. So between x squared and x, I have a common factor of x. And it's not cooperating here. And I would be, oh dear, I have a common factor of x, and I would be left with x plus 1. And between the last two terms, we have a common factor of y. Now, because of this minus, we're going to make the common factor negative y, and then we'll be left with x plus 1. With this method, what you're left with in brackets should always match up, okay, because that becomes your common factor actually on the next step. We'll take a common factor from those two groupings of x plus 1, and we'll be left with x minus y. Okay, let's try again in the next one. So we're going to group these two terms and these two terms. Common factor between the first two would be 2x, and when we divide that out, we'll be left with x plus 2. Common factor between the next two would be plus 3y, and we'll be left with 2 plus x. Now notice the ordering of the terms is different in the brackets, but x plus 2 and 2 plus x is the same thing. So my common factor becomes, on the next step, x plus 2 in brackets, and then I'll be left with 2x and plus 3y. Okay, let's try the last one like that. So grouping our terms together. Common factor between the first two would be 5m squared. When we divide that out, we'll be left with t minus 2. And the common factor between the last two would just be a t, and we would again be left with t minus 2. So our common factor on the last step is t minus 2 in brackets, and we'll be left with 5m squared plus t. And the last method we want to review today is decomposition. That's the method you need to use when the coefficient of your squared term is not 1. Okay, so that's what differentiates between the simple trinomials method and decomposition. There are some similarities. In fact, decomposition is kind of a combination of method 2 and method 3 here, your simple trinomials and your factoring by grouping. So what we do first with this method is we multiply these outside numbers together. So 6 times negative 12 is negative 72. Okay, so in this case, that becomes the product of the two numbers I'm looking for. So I need two numbers that multiply to negative 72 and add to negative 1. So, a positive 1. So the sum is 1. The coefficient of the middle term there, and the product is negative 72. Two numbers that multiply to negative 72 and add to 1 would be positive 9 and negative 8. So what we do is we rewrite the middle term as the sum of those numbers. So plus 9x minus 8x minus 12. That's why we call this method decomposition. We're decomposing that middle term, so that now I can factor by grouping here. So this is where that last method comes in. So my common factor between the first two terms would be 3x, which would leave me with 2x plus 3. And my common factor between the last two terms would be minus 4, which also leaves me with 2x plus 3. So in factored form, this one would be 2x plus 3 times 3x minus 4. Okay, let's try that again. So in the next question then, first thing, multiply those outside terms together. So we get negative 12, that's going to be our product, and negative 11 is going to be our sum. So two numbers that multiply to negative 12 and add to negative 11 would be negative 12 and 1. So we're going to rewrite that middle term as negative 12m plus 1m. Okay, and then we'll factor by grouping. So common factor between the first two terms is 4m, and you'll be left with m minus 3. Common factor between these last two is really just plus 1. They have nothing else in common, so once again it would be times m minus 3. So in factored form, this one will be m minus 3 times 4m plus 1. And lastly, multiplying the outside numbers gives us 30. So we need two numbers that have a product of 30 and a sum of 13. So two numbers that multiply to 30 and add to 13 would be 10 and 3. So we'll rewrite that 13a as plus 10a plus 3a. Then I can break this down factor by grouping. So my common factor here would be 2a, left with a plus 5, plus 3, again left with a plus 5. So in factored form, this one will be a plus 5 times 2a plus 3. And that concludes this lesson.